Kia ora, Year 11 and 12. This is a quick video revising quadratic expansions. It goes with Theta exercise 1302 on page 211 and also 1303. So what's a quadratic expansion? Well, when we have two linear expressions and we times them together, we get a quadratic expansion or a quadratic expression. So that's a really basic one. A harder one that we'll look at later in this video is one where we might have 2x plus 7 times x minus 3. Okay, but the basic idea is that we've got two terms and each of them is a linear expression. So when we want to multiply those together, let's see what we get. Just get a little bit more space here. So I'm going to go right back to Year 9 Algebra, and we're going to look at how we can draw a picture of x plus 2 times x plus 3. So we could think of x plus 3 as being the length of a rectangular paddock, and we could think of x plus 2 as being the width. And if we want to work out how they multiply together, we need to find the area of the whole thing. Now we're not going to do this beyond the first example. If this is way too slow, just forward through the video a little bit. So what does x plus 2 times x plus 3 mean? Well, it means x lots of x plus 3 plus 2 lots of x plus 3. This can really help if we come to harder quadratic expansions that we're having trouble with. Just go back to your distributive property. On the picture of the paddock, let's see where the x times x plus 3 lies. Well, here's x and here's my x plus 3. So we can shade that area in blue. And we can see that the 2 times x plus 3 is this yellow bit down here. Now we can break those up into 4 separate areas, and this is done when we expand each pair of brackets. So we've got x squared plus 3x plus 2x plus 3. And we can write those in on here. You can see there's my x squared. Oops, 2 3's are not 3, 2 3's are 6. So we've got x squared there, we've got 6 there. Here we've got 3x, and here we've got 2x. So to get our final answer, we collect up our like terms. And we get x squared plus 5x plus 6. Now that was really, really slow on purpose. Typically, many of you will use the acronym FOIL, which tells us to multiply the first two terms together first. That's our x squared. Then the outside ones, x times 3. Then the inside ones, 2 times x here. And finally, we do the last two, which is the 2 times the 3. Okay, so you might have a wee picture that goes something like this. First, inner, last, and those 1, 2, 3, 4. What we're going to do for the rest of this video is work through 6 examples that get more difficult, and then go and do exercise 1302 and 1303 in the textbook. Right, so I'm going to speed up significantly now. If we expand and simplify x plus 4 times x plus 9, we get x squared plus 9x plus 4x plus 36. We collect up our like terms, we get x squared plus 13x plus 36. Now the next one, I'm going to write out one extra step, which is that I've got x times x plus 6 minus 7 times x plus 6. So that gives me x squared plus 6x minus 7x minus 42, which is x squared minus x minus 42. If you're doing that straight with the FOIL method, remember, always keep the sign with the number straight after it. Right. The last one, 9 minus x times 2 plus x, we can again write out like this. So we get 9 times 2 plus x minus x times 2 plus x, or you could go straight to your own method of expanding. So we'd get 18 plus 9x minus 2x minus x squared, which gives me 18 plus 7x minus x squared. Right, or again, we could just do this, 18 plus 9x minus 2x minus x squared, and that would take me straight into this line here. It's fine either way, just always be careful with negative signs in these. Okay, on to the last slide just for 3 more examples. Right, so same idea here. We take the 2x and the 3x and we get 6x squared minus 1 times 2x gives me 2x minus 21x plus 7. 6x squared minus 23x plus 7. Now the next two are examples of what we call perfect squares. Really common mistake here is to forget what it really means, which is not x squared minus 5 squared, but x minus 5 times x minus 5. So always write that out if you've got a perfect square, and then it's the usual method. We'll get x squared minus 5x minus 5x again plus 25. Putting that all back together, we get x squared minus 10x plus 25. Right, now number 5 is the same idea, but with 2x minus 3. So write it out first. Right, so the first two together gives me 4x squared so it's 2x times 2x first, and the outer ones give me minus 6x, inner ones minus 6x again plus 9. It's worthwhile getting very fluent with the perfect square pattern so that you recognise it when we come to factorising in a couple of days. Okay, so we've got 4x squared minus 12x plus 9. Right, that's all for now. Ask me if you've got any problems. Thanks for watching.